Good morning to everyone present over here. Like,
Yes, good morning.
boss Smriti sir, Amin, and I came over here. Myself, Tanisha Shah, I came over here along with my team, Manisha and Sohani. Thank you, sir, for this opportunity with this conservation of momentum. So now I would like to call Sohani to demonstrate the project.
So hello and good morning to everyone, most especially sir and all my dear friends. So here we have a physics toy. It's called Nature's Cradle, and it is based on the principle of law of conservation of momentum. So as we already studied about the law of conservation of energy, that states that energy can neither be created nor destroyed. Similarly, we have the conservation of momentum, which states that total momentum before collision is equal to the total momentum after the collision. So let me show how. But to simplify things and make it easier to understand, instead of using 5 balls, we're just going to use 2 balls so there's there only one collision. Yeah. So when I pull this ball and release it, collision between the 2 balls happen. So one ball goes up and comes back down again and they collide again. So according to the principle of conservation of momentum, the total momentum in a collision is conserved for an isolated system with no external force applied. So here the isolated system are these two walls, and as we can already say that now there is no external force applied. So when these two balls will collide, the total momentum will be conserved. So now I would like to call Manisha to demonstrate it in more detail.
As you already studied about momentum and also know that the product of the momentum is known as the product of mass and velocity, and the symbol of momentum is P. So P equals to mv, and that's the formula of momentum. So the momentum of the ball gets transferred into during the collision, and the other ball during the collision, and similarly when so I would like to demonstrate again to show. Similarly, when a ball falls from a height, its potential energy gets transferred into kinetic energy, and the other ball during collision gets transferred into potential energy, and then again comes back to kinetic energy, and the total energy of the system gets conserved. So if there was no air friction and energy losses, then the oscillations would keep continuing on and on forever.
And what are the use of these balls?
Yes, we can.
You have used so many marbles in balls, right? What are the uses of other balls?
So because when we can also use the 5 balls, but the collision will be same.
Well, sure.
The result will be same. Similarly, when we use 5 balls instead of 2 balls, the result will be same.
Good. Okay, clap for them. What is the SI unit of momentum? What is the SI unit of momentum? Very simple question because the topic is just momentum and you have used this term many times. Kilogram? Good. Next. Momentum is a scalar quantity or vector quantity. Also give the reason why. Look there. Scalar quantity. Is it? Come here, you come. Is it scalar? What is the quantity of momentum? Vector or scalar? And why? This is the simplest question that our Miss Anish,
Yes, sir.
come here. Can you give the answer? Momentum is scalar or vector?
Vector one.
Why?
Because it has direction.
It has direction as well as magnitude. So this is the product of mass and velocity, right? So velocity is the vector. The vector into scalar is like scalar, a vector. Understand? It is mass and magnitude. So you state this as second law
Second law.
because momentum is on best on second law. Second law of motion.
So the total collision before total momentum before collision equals to
It is a conservation moment. You are saying about conservation moment. State the second law of motion, or in reality, if I say that, state me the law of momentum. The rate of change of is directly proportional to the applied unbalanced force. Okay, thank you so much.